Welcome to Module 5, Minimal Impact Design Standards and MIDS Calculator, Bioretention. If you'd like to see the other modules, you can go to this page in the Minnesota Stormwater Manual, or copy and paste this link into your browser, and it will take you to that page in the manual where you can see the other modules. In this module, we will be covering bioretention, as I said. Fairly lengthy module because we'll be going through a number of examples. First, I'm going to go to the guidance and resources in the Minnesota Stormwater Manual. There are two basic BMPs in the calculator for bioretention, one with no underdrain and one with an underdrain. We're going to be covering both of those in this module. With the bioinfiltration is what we call one with no underdrain. For biofiltration, even though it's just one BMP, we have the option of having the underdrain at different positions, either at the bottom of the BMP or raising it. So we'll go through an example of each of those. And then we'll go through finally an example where we use biofiltration and bioinfiltration together in the calculator. And I'll just rehash the guidance and resources because those are available in the manual and these should be very helpful to you. So we'll escape again and go into the Minnesota Stormwater Manual. Now we're in the table of contents here in the manual, and if you scroll down to either filtration or infiltration practices, you can get at bioretention there. And I'll click on infiltration, and you'll see that bioretention is here. This will also take you to the biofiltration section because they are combined in the manual. What we're interested in is these two pages here, requirements, recommendations, and information for using bioretention with no underdrain BMPs in the MIDS calculator, or the same file for using BMP with an underdrain in the MIDS calculator. These are both essentially the same, except one deals with no underdrain and the other deals with a situation where you do have an underdrain. If you hover over on the right part of the screen here over page contents, it will show you what is on this page, and you'll see it talks a little bit about the MIDS calculator and the inputs for bioinfiltration in this case, which is no underdrain. We'll talk about the model input requirements, the methodology, routing, assumptions, a few other things here, and then finally there will be an example. There'll be an example here at number 6, and then some wrap-up information. So if you scroll down, you'll see images of the calculator. Those are linked with text on the left here. The methodology that's being used to generate the credits for volume, phosphorus, and TSS. And then here's the example that's in the manual. Same page exists for a situation where you have an underdrain. Again, if you hover over the page contents, you see that this page is much longer because we're dealing with different types of scenarios where we raise the underdrain or have it at the bottom of the underdrain. You also have a evapotranspiration credit for this particular BMP, which you don't have when you have no underdrain. So we'll escape from the manual and go to the MIDS calculator. We'll maximize this to get rid of that screen. And then we're going to create a new file. And we'll call this bioretention. Save the file. It should pop up fairly quickly. And so first site information is needed. If you saw Module 2, you'll remember that you need to have certain information input here to get to the schematic tab where you can actually drop your BMPs and work with them. So the first question we need to answer is whether we're trying to comply with a construction stormwater permit. Let's say no. We'll leave our defaults, the retention requirements, phosphorus, and the TSS. We'll leave those as they are. We'll input a zip code, 55155. That will give us the rainfall information. And then finally, for this particular example, we're going to have 1 acre of impervious, and we're going to have 1 acre of turf on a beach soil. With that, then we can proceed to our schematic tab. And you'll see on the left here that again it's been populated with our information about the site and the performance goal, which is 3,993 cubic feet. We're going to start with the first BMP, which is bioretention with no underdrain. Here are the 2 bioretention BMPs. The first one, the top one, is bioretention with no underdrain. You click on it and hold the button down and drag it onto your screen. Now I can work with this BMP. I can either double click on the BMP or right click and edit the BMP properties. I chose to right click and edit the BMP properties, and then this screen opens up. So now I'm in the bioretention basin without an underdrain screen. And here's where I have to put information about the site and how much is draining to that particular BMP. And then I'll have a couple other tabs we'll take a look at here. So I'm going to drain or route the entire site to this practice. That would be 1 acre of managed turf on B soils, 1 acre of impervious surface. If I click OK, it will exit me from the screen, so I want to click on the BMP Parameters tab to get to the next screen. And here's where I need to input information about this particular practice. We want this to comply with the performance goal, so let's just make it easy and enter a top surface area of 3,993 cubic feet. The media surface area, so we have water ponded here from the outlet down to the top of the media. So water is going to be ponded there. This surface here, we're also going to make 3,993 cubic feet just for simplicity. And this ponded depth or overflow depth here, we're going to make it 1 foot. And using those dimensions, you should see that we would be able to comply with the performance goal. Our underlying soil we're going to have a B soil with infiltration rate of 0.45 inches per hour. That 1 inch, that 1 foot of water is going to have to draw down in 48 hours. And when I do that, you'll see some numbers pop up here, and you'll see that it's telling me how much volume reduction capacity I have for the BMP and how much retention is being provided by the BMP. If I was to go to the BMP summary for this particular practice, you'll see that I am meeting my performance goal 100%. And it will give you some annual information here. I'm retaining 90% of my annual runoff and phosphorus and 90% of my annual TSS. Everything that's being infiltrated is taking those pollutants and retaining them. Water that bypasses this for larger storms, for example, than 1.1 inch, is not treated by this practice. A couple things here about this practice. If I had an overflow depth of 2 feet, for example, I would get an error message telling me that I cannot be greater than 1.5 feet for a bioretention system. And if you go to the manual, you'll find out that that, in fact, is a recommendation. And that's because we have plants in the system. We don't want to inundate the plants. Also, if I go back to 1 here, and let's just say I've made put a D soil underneath, I get another error message saying that I'm not meeting my drawdown time. So this 1 foot is not being drawn down adequately in this scenario. So I have to go back in and find a soil that will take a foot of water if that's the depth that I want. So I'm happy with this BMP. I click on OK. And I can go to it takes me back to my main set of screens, and I can go to my results here and look at my results. And this provides a summary of my site information. It talks a little bit about the site area, the land cover, and then the summary information down here. I'm meeting my performance goal and retaining 90% of my volume on an annual basis, as well as my phosphorus and TSS. Now I'm going to go back into this. I'm going to add another practice. In fact, I'll add 2. And so now I've got 3 bioretention systems. I'm going to go back into this first one, and I'm going to change the parameters tab. I'm going to route only a half an acre to this one, and then a half an acre. So I'm routing half of my pervious and half of my impervious. And I'm going to route this BMP to that 3rd bioretention system, because this one's not going to give me my performance goal. So if I go into the BMP parameters tab, I could leave that the same as if I wanted to, but I'm going to make this a little bit smaller so that we're not capturing much water here. We're only getting, you can see, about half of our performance goal. So I'm going to click OK, and you can see now that there's an arrow, and this is being routed, this BMP is being routed to this bioretention basin. I'll go into this BMP. I'll route my other half acre of pervious and impervious to this practice. And if you remember, I have not done anything with this BMP, so I have to provide all new inputs here. I'm going to make this quite a bit smaller. I'll make it 1,000 square foot size. I'll only put half a foot of water ponded into this. I'll have the same soil underneath with a drawdown time of 48 hours. And you'll see that I'm not really achieving much volume reduction here. So I'll click OK, and you can see that this one's not routed because I forgot to route it. So if you go back here, you have to route that to the 3rd practice or to the other practice if you wanted to route this BMP to another practice. And now you can see that both these BMPs are being routed to this 3rd BMP. So here, I'm not going to route any pervious or impervious because all of it's been routed, but I am going to go in and try to design this system so that I meet my performance goal. So you can see that my required treatment volume is 1496, and that's all coming from those other two BMPs. So 1,496 cubic feet of water is coming from these 2 other practices because I'm not routing any impervious to this. So I'll go in and I'll size this so that it meets the performance goal, do the easy calculations, 1 foot of ponded water, the B soil underneath, and a required drawdown time of 48 hours. And if we go to our BMP summary, I am now meeting my performance goal 100%, and I'm getting 92% of my annual volume. And you notice that these numbers are slightly larger than the 90% we're achieving with just 1 BMP, and that's because as water infiltrates into the system, it's assumed to be captured instantaneously. In fact, water does continue to enter the system even during a rainstorm, so we are getting some slight increase in volume as a result of that. So we click OK, and that is our no underdrain system. Now let's get rid of these BMPs. We're going to deal with bioretention. It takes a little while to right click on the BMP. You can click delete. And so I'll get rid of these. Now we're going to go to bioretention with an underdrain. So let's click and drag that BMP on here. And we're going to have the same site. We're going to have 1 acre of turf on B soils, 1 acre of impervious. We'll click on the BMP parameters tab. And then you can see this screen is much more complicated than the one with no underdrain. Our treatment volume is the same, 3,993, but we are going to put an underdrain in the system. We're going to start with one that is not elevated. So this question is the underdrain elevated above native soils? And the answer is no. So we're going to put this under drain here at the bottom of our practice. So it would be here in the schematic if we get a schematic showing that. The next two questions are asking if it's lined, if the BMP is lined, and the answer to that is no. There are some situations where you would have to line this BMP. For example, if it was over karst or over contaminated soils, you would have to line this practice. So we're going to use the same values that we had previously to the no underdrain system, 3,993 square feet. We're going to make it 3,993 square feet throughout the system. For simplicity's sake, again, we'll put a 1 foot overflow depth on it. And then it asks me an additional question here, what is the media depth? And we're going to make the media depth about, let's say, 2 feet for now. There's some other questions. It's going to ask you the media field capacity minus wilting point. That's because this is going to get an evapotranspiration credit. It gives you a recommended range. We're going to put in the midpoint of that range. It asks you for the media porosity minus field capacity. And that we're going to put in again as a mid-range value of 0.25. It's asking now if I want to put a tree in the system. We're going to say no. If we put a tree in, we'll get a higher evapotranspiration credit than we would if we said no. It asks me the bioretention planting mix. And I have some options here. In the manual, it talks about each of these mixes. The reason it's asking you this is because it's related to a phosphorus credit. If I took mix A, for now we'll take mix A, it's asking me, is the P content of the media less than 30 milligrams per kilogram? And I'll have to answer yes or no. If I pick mix C, this screen grays out because we are assuming that with this particular mix that we have a low phosphorus concentration that's going to would answer yes to this automatically. So we'll go back and we'll put in a value of media mix A, and we'll say that our mix is not less than 30 milligrams per kilogram. So this is related to the phosphorus credit. Another question related to the phosphorus credit is a soil amendment used to attenuate phosphorus? This might be iron-enhanced system, for example, and we are going to say no for now. The underlying soil, we're going to have a fairly permeable soil, even though we have an underdrain. So it'll be a beach soil with an infiltration rate of 0.45 centimeters per hour, inches per hour. We need to draw this down in 48 hours. So we've got a system input. Let's take a little look here. We can go to BMP summary and look at the results. We can also see them, the volume results here on the screen. And you'll see that we're getting a volume reduction from the bottom. So that's water that's infiltrating along the side slopes. If we had side slopes in this system, we don't because the bottom area is the same as the top. But we are getting some infiltration through the bottom of the system, 958 cubic feet. We're also getting a 100 cubic foot credit for evapotranspiration. If we go back and put a tree into this system, that number should increase, and it does, 299 cubic feet with the tree in this bioretention system. To see the phosphorus and the TSS results, we have to go to this BMP summary tab, and you'll see here that we're not even close to meeting our performance goal. We're at 32% achieved. So we're only infiltrating a small amount of water compared to the previous example where we did not have an. We are getting a fairly high TSS reduction, but not a very good reduction in phosphorus. And the reason for that is because back here we are using mix A, and we have not tested it, or it comes back with a high concentration of phosphorus. So this mix is actually potentially leaching phosphorus, and we're not getting very good phosphorus credit for this. Since we're not meeting our performance goal, we'll click OK here. Since we're not meeting our performance goal, let's put in a second practice, bioretention system. And let's double click on this. And let's not route anything to this except this first BMP. Let's go ahead and route that first BMP to the second one. So now you can see that the second practice, we're not going to route any pervious or impervious surface, but it does have a retention requirement because the water that's not being treated in that first BMP is being routed to this BMP. So with this one, I'm going to elevate the underdrain. So I'll say yes to whether it's elevated, and then I'll say no to whether it's lined or not. We'll make this a bit smaller, the system. So we have 1,000 square feet surface areas. And you can see that it's asking me what the area is at the underdrain, which it didn't previously because the underdrain was at the bottom, which would be the same as this bottom surface area. And just as a note, you cannot have these dimensions larger than any area above it. You get an error value. So this has to be smaller or equal to any size for any area that is above that particular feature. The overflow depth, again, we'll go with 1 foot. Media depth, in this case, we're going to have it at 2 feet. And the depth below the underdrain, so how much are we raising this underdrain above the bottom? And let's go ahead and raise it by a 1/2 foot. Again, the media field capacity minus wilting point, this is for evapotranspiration credits. Media porosity minus field capacity, we'll go again with the mid-range. We are not going to have a tree in this system. We're going to go with mix C in this case, so we don't have to test it because it's assumed to have a low phosphorus concentration. We are not going to have an amendment. We can add an amendment here shortly. I can show you the effect that'll have. Again, the underlying soil is a B, 0.45 inches per hour, and a drawdown time of 48 hours. And when I do that, you'll see that it's getting populated here. So now I'm getting infiltration, as I did previously, through the bottom. I'm also getting evapotranspiration credit, but now I'm also getting a volume reduction for water that's stored below the underdrain. And that's, in this case, 125 cubic feet of water is being stored below the underdrain, and eventually that water will infiltrate, so you're getting that credit. If we were to raise this underdrain, for example, to 1 foot, you'll see this number jump. It should double, and it did. So now we have 250 cubic feet of water being stored below here. Again, if I wanted to see the phosphorus and TSS information, I'd have to go to this BMP summary tab. And that information is shown down here. So my dissolved phosphorus is 49%, particular phosphorus is 89%. Let's go back and add an amendment. So remember, 49% of dissolved phosphorus is being removed. So if we go back here and add an amendment, this would be an iron enhanced amendment, for example, to this soil. Now let's go in and take a look at that dissolved phosphorus number, and you'll see that it's jumped to 72%. It was 49%. So by adding an iron enhancement to this BMP, we've increased our phosphorus retention. So even with these 2 BMPs, though, we're still not meeting our performance goal. So we'll click OK and add a third system. Now we're going to add a bio-infiltration system. This is a bioretention with no underdrain. We're going to route the second BMP to that third BMP. Click OK. And so now, this is, again, we're not going to route anything to this in terms of pervious or impervious surface, but you'll see that if you click on the BMP Parameters tab, that we're getting water that's coming from these two BMPs that was not captured fully by those two practices. So we'll go ahead and size this one so that it meets the retention requirement. Again, we use very simple numbers to illustrate that. 1 foot overflow depth with a fairly pervious under soil, a B soil of 0.45 inches per hour. Retention, or drawdown time of 48 hours. And that should meet our performance goal now. If we go to the BMP summary, we are now meeting our performance goal. We're getting 90% removal for phosphorus and TSS. And so we can click OK, and here's the pounds if you're interested in pounds. Now to look at the full site information, we would go to the Results tab on the main screen, main set of screens here. And here again, site information, total site area, the routing information. And then as you go down here, you'll see that you'll have these BMP summaries. The performance goal, the annual summary, particular phosphorus, which is all phosphorus. If we go down just a little bit farther, you see the TSS summary. And it shows them for each of the BMPs. So looking just at annual volume, for example, we can see that that first bioretention system with an underdrain is getting this much volume on an annual basis. The second one's getting this. And then that bioinfiltration without an underdrain is capturing the remainder of the water. Same type of information in these other boxes showing how each of the best management practices is performing. Now, you'll notice it can get a little confusing here with the names. So when you're into these practices, it might be a good idea to go in here and change the BMP name if that helps you orient yourself to what's going on in this particular system. A lot of information here. We've covered bioinfiltration by itself, bioretention with an underdrain at the bottom, and this one with an underdrain raised above the bottom. We showed you the P reduction and how it's affected by the amendments and the type of soil that media mix that you use. And then finally we had this little treatment train where we routed these two underdrain systems to a bioinfiltration system which does not have an underdrain to it. Just as a reminder, I'll go back into the manual here and remind you that all that information is contained on these requirements, recommendations, and information for using bioretention pages. One for with an underdrain and one page without an underdrain. To get to those, you can get to those in two ways. You can get to them through the bioretention BMP. So those two pages would be here. Or you can get to them through the MIDS page. So I'm going back to the table of contents. You'll see the MIDS page right here. If I click on that, it'll take me to that MIDS portal. And here you'll see requirements, recommendations, and information for using specific BMPs in the MIDS calculator. You click on that page, and you look for bioinfiltration or biofiltration, and it'll take you to those same pages that I showed you before. These pages are very useful. If the module is a little bit confusing in a couple places, go to these pages. It will walk you through all the inputs and an example also on this page. So a lot of information, as I said, in this particular module. If you want to see those other modules, you can go to this link in the manual or to this page in the manual. And that ends Module 5, Bioretention.